All right, so
What is it?
there's an easy way and there's a hard way to do this problem, okay? It says find the area of the circle S, okay? So in order, we know the area of this little segment over here, this sector of the circle, okay? So we say that 48 is equal to what? Mariana?
5 times 135.
Close. 135, though, is not our radius. That's the degrees.
You would do 48 feet squared is equal to 135 over 360 times pi r squared.
Very good. Pi r squared. Now, guys, I want to show you the easy way to do this, okay? We're looking for the area of the whole circle, right? We're looking for the area of the whole circle. Instead of pi r squared, cross it out and just put area of circle S. Because you guys agree that 135 over 360 is going to tell us, okay, this is that portion of the circle. It's 135 degrees out of 360. So it's that portion, it's the red portion of the circle. You guys agree with that? So it's that portion of the area. So all we need to do for this problem is not find the radius, just multiply the whole thing by 360 over 135. Those of you that found the radius, try this, write this down, and see if you get the exact same answer, okay? We multiplied by the reciprocal, and see if you get the exact same answer that you got when you did calculate the radius. And that answer should be, let's plug it in, 360 times 48 divided by 135, 128. The area of circle C, or S, excuse me, is 128, and it's feet squared. So if you did the radius problem, right, you plugged it in, found your radius, used that radius with pi and everything, you should have gotten approximately the same value, okay? But remember, you don't need to find the radius, okay? You just needed to have it as the area of the circle S. .3 is the area of polygons, okay? So we're no longer talking about circles right now, we're talking about polygons, but there are still going to be circles in this lesson. All right, so first thing that you guys need to know is the area of a rhombus or a kite. And before we talk about the areas, guys, what is a rhombus? Does anyone remember what a rhombus is? Xavier?
All 4 sides are congruent.
Very good, write that in there. All 4 sides are congruent. There's a shape that's a specific kind of rhombus. Does anyone remember what shape is a specific? No, a kite's different than a rhombus. A square, very good. But what's more specific about a square? A square has to have what else? 4 right angles, okay? A rhombus does not. Do you guys see how these lengths are all the same, but the angles do not necessarily have to be 90 degrees there? Okay? It's just considered like a parallelogram, right? Doesn't have to have those 90 degrees angles, okay? And then for a kite, do you guys remember what a kite was? Very good. 2, and we say that they're adjacent, congruent sides. What does adjacent mean? They're next to each other, okay? The reason we have to specify that they're adjacent, because wouldn't a rectangle be a kite if they didn't have to be next to each other?
Yeah.
Does a rectangle have 2 sets of congruent sides?
Yeah.
Yes, but those sides are opposite each other. Do you guys see the difference there? So a kite, the 2 adjacent sides need to be congruent. Does that make sense?
Yeah.
All right, so notice your 2 congruence marks are going to be next to each other versus across from each other. All right? Now, the really convenient, super easy to use formula is 1/2 the diagonal times the other diagonal. So whatever your first diagonal is, you multiply by the second diagonal and divide by 2, and that will give you the area of these figures. So, really quickly, I want you guys to use a highlighter, okay? Because sometimes these pictures can be a little bit difficult to see. diagonal 1, I want you to highlight down here. That's the same as this length inside. Do you guys see that? Sometimes they write it outside because when they're labeling, it can be a little bit confusing. Use a different color, highlight diagonal 2, and that's the diagonal going from the top vertex down to the bottom. Let's do the same thing for the kite. So we're going to put diagonal 1, which is the horizontal one, in red, and we'll put the second diagonal in blue. Okay? So even though they're labeling it outside the figure, okay, it is a line that's drawn inside the figure. Cool beans? All right, any questions so far? This theorem, and we actually can. Okay, so let's prove it together. Let's walk through it. So, I did. Is yours? I know, but yours doesn't say, can we prove it? Okay, then skip to this one, okay? Can we prove it? Really quickly, guys, okay? Do you guys remember what happens in a rhombus? What's true about their diagonals? Gabby? Excellent, they're perpendicular. So draw a perpendicular mark right there, okay? Let's go ahead and try to find the length or the area of one of these triangles, okay? Let's go ahead and try to find the area of one of these triangles. Let's go ahead and pick this one, okay? Now, if you don't remember, the area of a triangle is 1/2 the base times the height. We'll label this the base and this the height. Okay? There was another property inside a rhombus about the diagonals. Does anyone remember it? Xavier? Very good. They also bisect each other. So really quickly, guys, draw a congruence mark on the base. These two have to be the same length. Do you guys agree with that?
Yeah.
And the heights have to be the same length. Do you guys agree with that? That's all we need, okay? Now, let's try to write the base in terms of the first diagonal, right? Our base is the same as what portion of our first diagonal? Very good, half of it. So let's write that in there. So our area is equal to 1/2. Instead of B, we're going to put 1/2 whatever D1 was. Do you guys see that? Because diagonal 1 is cut in half. Do you guys kind of see that?
Yeah.
Okay, so we're going to say 1/2 times D1. How could we rewrite H? Jaden?
1/2 of D2.
Very good. 1/2 of D2. Look at it for a second. Do you guys kind of understand what I'm doing? I'm just taking the full diagonal, dividing it by 2, that'll be my height. Taking the full diagonal, dividing it by 2, that'll be my base. You guys cool with that? Okay, now let's multiply all these together. You're gonna get that the area is 1 over, what's 2 times 2 times 2? 8. D1, D2. Are you guys cool with that? That I can multiply coefficients, right, and keep my variables the same? So it would be 1/2 times 1/2, which would give me 1/4, times 1/2 again, which gives me 1/8, right? Now, these triangles, how many triangles do we have in our figure? How many of those right triangles do we have? 4 of them. So the area of the rhombus is take this area and multiply it by 4. So we do 4 times 1/8 times D1, D2. What is this going to give me? Xavier?
1/2 times D1.
Say, what? Did we just prove that? Do you guys see how cool that is? So they proved it by finding the area of one right triangle and then taking that and multiplying it by 4 because there's 1, 2, 3, 4 of the exact same triangle, okay? So the area of a rhombus is 4 over 8 D1, D2, which Xavier just said simplifies to 1/2 D1, D2. Cute little proof, okay? Again, do we need to know proofs for our test or our quiz? No, okay? But it's cool to see like where this stuff is coming from, right? Because it's one thing for me to just give you a formula, but I would like you guys to understand where it's coming from, okay? I'm waiting. Where does yours... How would we do A? Jaden. Very good. Area equals 1/2 your D1 times your D2. You can label this one D1, this one D2. Doesn't matter, okay? Either one can be either one. You're just going to do area equals 1/2 times 8 times 6. And that will give me what? Calculators, 0.5 times 8 times 6, 24. But what units do I need? Meters squared. Why? Because it's area. Very good. Okay, yeah, Gabby? Yes, you will still have calculators for chapter 11. Okay? All right, let's do B. What kind of shape is B? The first one was a rhombus, right? This one's a kite. Can we use the formula? Yes, it's the same formula for both of those shapes. So let's make this D1. Let's make this one D2. We're just going to say that our area is 1/2, 10 times 7. Does it matter the order? No, not really, okay? So we would do 1/2 times 70, which is 35. And we put centimeters squared. Pretty basic, right? All right. Now, one thing to keep in mind, guys, right? If they were giving you certain segments in this figure, just remember, each time you draw a diagonal in either a kite or a parallelogram, they're going to form 90-degree angles, and the segments that are formed are going to be bisected, okay? So there's going to be like some symmetry there. Nope, that was wrong. For the kite, though, only these two sides are going to be congruent, okay? These are clearly not the same size. All right, questions? Yeah, Savannah. No. Okay. All right. So, a regular polygon, okay? There are certain parts of a regular polygon that we need to know, okay? First off, guys, stop writing. I know there's blanks on your page. Before we start writing, what is a regular polygon? Does anyone remember what a regular polygon is? Giselle? Congruent what? Very good. It has all congruent sides and all congruent angles. Write that in there, okay? Super important. All congruent sides plus angles. Cool beans? Okay? So it's almost like the perfect shape. So if you have a regular pentagon, all 5 of those sides need to be the same length, and all 5 of those angles need to be the same measure. Okay, now you can copy down, okay? The center of a polygon is the center of the circumscribed circle. So you're going to imagine a shape. You're going to imagine that there's a circle that circumscribes your shape, okay? The center will be the center of the circle that includes your figure, okay? Now, if you look down below, they have a hexagon for you. And do you see how they drew a circle around the hexagon? The center of that circle would be the center of your polygon, okay? The radius of the circumscribed circle, okay? It's also the distance from the center of your figure to any of the vertexes, okay? Because all of the vertexes will lie on the edge of the circle. Your central angle is formed by 2 radii drawn to consecutive vertices, okay? So what I want you guys to do is next to central angle, what would be the central angle of the figure drawn below? Don't say angle P because there's 2 angles there. MPN, very good. MPN. Do you guys see that? MPN. Remember, it's formed by 2 of the radiuses, or radii, okay? Now, the one word that's very different that we have not seen before is called the apothem, okay? An apothem is the perpendicular distance from the center of the polygon to a side. Which segment represents the apothem in this figure? Xavier? It is not MN. MN is actually one of the sides. PQ, very good. PQ. Make sure it's a segment because it does start and it does end. Starts from the center and it's the distance from the center to a side of the polygon. Remember, distance from a point to a line must form a 90-degree angle. That's why there's a perpendicular sign there, okay? Who needs to still write down stuff on this slide? We're Gucci? We're going to make it, okay? All right. Now, one thing that you need to know, a central angle, you just take the number of sides of your polygon and you divide that from 360. And that will tell you the measure of each of your central angles, okay? So let's say in our previous example, we had a hexagon, right? Write this down. What's the measure of a central angle? 360 divided by 6, because n is equal to 6. So the measure of each of the central angles is 60 degrees. Now, the cool part is that because these are regular polygons, all the angles, all the sides are the same, okay? Every single side and every single angle is going to look exactly the same for the entire figure, okay? But it's because they're regular polygons. In the diagram, WXYZ is a square inscribed in circle P, okay? Identify the center. Yep, excellent, it's point P. Identify the radius, or a radius. Jaden? XP, I agree. Okay, notice it goes from the edge of the circle to the middle. What's another radius? YP, okay? What's the apothem? Mariana? It's PQ, very good. PQ. What's the central angle? Be careful here. What's the central angle? Talia?
P or Q?
It does include P.
Oh, no.
Jaden?
90 degrees.
Where's that?
No.
Did you say F?
Zoe?
At the corner.
Angle XPY.
Very good. It's angle XPY. Do you guys see that? Follow it along. Do you see how the two radii create this angle? Now, Jaden, what is the measure of this angle?
90 degrees.
How did you know?
Because I did 360 divided by 4.
Very good. It is 90 degrees because it's 360 divided by 4. Do we see that? Because our figure was a four-sided figure. All right. What would be the measure of PXPY? We just found that it was 90 degrees. What would be the measure of XPQ? XPQ. Xavier? 45. Why? Very good. You just take whatever angle you had for the central angle and you divide it by 2. So write down it's 90 divided by 2. And what would be PXQ? If this one's 45, what does this angle have to be, Zoe?
45.
Excellent, because it's part of a 45, 45, 90. Yes. Mm-hmm. Oh, whoops, hold on. Area of an n-gon with side length s is 1/2 the product of the apothem and the perimeter, okay? Now, your perimeter, okay, there's two formulas written here, but they're the exact same, okay? You can either write it with perimeter as P, or you can write the perimeter as n times s, where n is the number of sides times s, which is the length of each side. Why could we write the perimeter as n times s?
Because perimeter is the number of sides.
Yeah, but why is the perimeter equal to the number of sides times any of the side lengths?
I don't know. You're the teacher.
I'm not.
It's a regular polygon. Remember that. So all the sides are what? The same length. So can we just take the number of sides and multiply them by one of the sides? Right? And we would get the perimeter. Okay? So it's super important that you guys know both of these equations because we're going to be using both of them. Okay? One thing that I want you to notice. Okay? Do you see how it spells ANS in the bottom one? That's the way that you can remember the formula. because I think of ANS as like the answer, right? So it's 1/2 the answer. So your area is 1/2 apothem times number of sides times the side. Cool? All right, let's do this formula. Find the perimeter and area of each figure. So we're finding perimeter and area. A regular hexagon with apothem 6, okay? For these figures, for these examples, you should absolutely draw a picture, okay? So if it's a hexagon, how many sides does it have? So we're going to write n equals 6, and apothem is 6, so we're going to write a equals 6. You guys cool with that? Now, what would the perimeter be? Well, we don't know the side length, do we? So we have to draw a picture. So draw a circle.
Why is the apothem 6?
What do you mean, why is the apothem 6?
Because the apothem is the number of sides.
What's that?
How did you...
So that's why we have to draw a picture, okay? So draw a circle, and then draw, to the best of your abilities, a hexagon around that circle. Mine is not going to be as good as yours. Okay. Draw your center and draw a radius. Remember, a radius has to go to the edge of the circle. All right, guys. Where would my apothem go?
On the black line, I think.
It would go from the middle to where? To a side. So draw your apothem like this.
Uh-oh.
Now, apothems are always, they create what kind of angle with the side?
Right.
A right angle. So draw in that right angle. And we said that the apothem here was how many degrees? Or how long? It was 6, right?
I'm struggling to draw this.
Okay. Now, we need to figure out, okay, what is this angle? We can't move forward until we figure out this angle, right? And we figure out this angle by taking 360. We're going to write that this is x degrees. X degrees is equal to 360 divided by the number of sides times 2. What was the number of sides here? 6, but also divide it by 2. So we're going to get 360 divided by 12. Okay? Because this is half of a central angle. Do you guys agree that this would be a central angle?
Yeah.
So x is going to be half of it. Okay? So we do 360 divided by 12, and that'll give us that this angle is 30 degrees. Why did I times 2? Because we need to do half of it, right? If we take the degrees 360, right, and divide it by the number of sides, we're going to get this angle, this central angle, right? But this is half of a central angle. So we have to divide it by 2 as well. You can think about it as doing 360 divided by 6. You'd get 60, and then divide that by 2, okay? So we have 30 degrees. So this angle is 30 degrees. What does that mean this angle is? It's 60, okay? So this is a 30, 60, 90. Do you remember that? So what we care about, right, is we care about the side length, right? We care about this side. This is going to be exactly 1/2 the length of the side, right? Because the side is going to be this whole thing. Okay? So this is a 30, 60, 90 triangle. The side opposite the 60 is 6. The side opposite the 30 will be this 1/2 s, which we need to figure out. Okay? So what we have to do is label this A. Label this A times the square root of 3. And label this 2A. In order to find A, we have to solve this one, okay? So we're going to set 6 equal to A times the square root of 3. Divide both sides by the square root of 3. And you're going to get A equals 6 divided by the square root of 3 is 3.4641 ... We'll round that. We'll say A is equal to 3.5. Okay, so this side length over here is 3.5. That is not the length of the entire side, though. What do we have to do with that value? Jaden? Multiply it by 2, because there's 2 pieces to this side. So we multiply that by 2, we're going to get 7. So our side length is 7. Okay? Now, if the side length is 7, let's go ahead and find our perimeter of the figure. So remember, perimeter is going to be the number of sides times the side length. How many sides does this figure have? 6. And what was each side length? 7. So you take 6 times 7 and you get 42. So our perimeter is 42. And what units was this in? There were no units. We're just going to put units squared. So our perimeter is 42 units squared. And we're going to use that value to plug it into our formula. So we're going to say area equals 1/2 Apothem times perimeter. You can use A and S, but remember we just found what N times S was, because that's the same as the perimeter. And this is going to be 1/2 times 6 times 42, which is going to be 3 times 42, which is 126. And this one also, perimeter, guys, should not be squared. I messed up there. Because perimeter is just the length, right? It's the length all the way around. This should be units squared when you're talking about your area. Another octagon with side 5 and apothem 3, okay? How many sides is an octagon?
8.
So n equals 8. S equals 5. And apothem was 3. Do we need to draw a picture for this one? No, because we're given all the information. So the perimeter is going to be what? 5 times 8. The n times the s. So perimeter is going to be 8 times 5, which will be 40. That's just units. How would I find the area? 1/2 times the apothem times the perimeter, right? Or you can just do A and S, right? But we just found what N times S was. So our area is going to be 1/2 times the apothem, which is 3, and then times the perimeter. And this will give me an area of 3 times 0.5 times 40, should be 60 units squared. So guys, if it gives you the side, the apothem, and the number of sides, okay, for an octagon it's at 8, right? They're super easy problems, but when they don't give you one of the pieces of information, you have to use a diagram to solve for it, okay? Which is 40. All right, one more example. An equilateral triangle with apothem 8. Equilateral means what? All the sides and all the angles are equal. Therefore, we can say it's the same as regular, right? All right, so it's a regular triangle. How many sides does a triangle have? N equals 3. And our apothem is 8. Okay? So we still need to draw a picture. Go ahead and draw a triangle. Try to make all sides as equal as you can. And then draw a circle around that triangle. Okay? Find the center. Draw a radius and an apothem. You should get a right triangle. Do you guys all see that? Now, the angle that's formed, we can find it by doing 360 divided by the number of sides times 2. So we do 360 divided by 3 times 2. Therefore, 360 divided by 6. This is going to give me 60 degrees. So we know this angle is 60 degrees. Therefore, this angle over here has to be 30 degrees. We were told that the apothem is 8. So all we need to do is find the length of each side. Now, we used 30, 60, 90 on the last problem, right? You can use 30, 60, 90 again, but let's say you forgot what 30, 60, 90 is. You could also use tangent here, okay? So, let's say we want to do the tangent of 30 degrees, right? So look at the 30-degree angle, right? Tangent is opposite over opposite over adjacent. Do you guys agree? What's opposite the 30 here? Xavier? The 8, right? So the tangent of 30 is going to be 8 over this side, right? 8 over, we'll label it y. Okay, so you can do y equals 8 divided by the tangent of 30 degrees, or you can just use the fact that it's a 30, 60, 90, and take the 8 and multiply by the square root of 3. All right, but I want to show you two different ways in case you want two different ways of doing it. So 8 divided by the tangent of 30 is going to give me 13.856. So y equals 13.9. But that is not the length of the entire side. You have to take that and do what with it? Multiply it by 2. So we're going to get that the entire side length is 13.9. Take that value, multiply it by 2. 27.7 or 0.8. Yes, because if you rounded it, you should get 27.8. This is, we don't have units, so we're just going to label it units. Once we find the side, we have enough information to solve this, okay? We have n, we have a, and we have s. The perimeter is going to be n times s, which will be 3 times 27.8. Which is 83.4 units. And the area will be 1/2 apothem times perimeter. So the area will be 1/2 times apothem was 8 and perimeter was 83.4. 333.6 units squared.